Hello. So today we're going to be talking about more properties of logarithms. We started solving basic logarithmic equations yesterday, and today we're going to, learn a few more ideas that will help us solve more complex ones. So the first one here, this rule stating that if we have two logarithms being added together, right here, and as long as they have the same base, and b cannot be 1, we can combine them into one logarithm by multiplying these two pieces, the m and the n. And notice we got division here. If we have subtraction of two logarithms that have the same base, b, we can put the first one over the second one. So you put the first one over the second one. So hopefully you're looking at this and you're thinking that this relates to exponential rules as well. You think about you have two bases that are the same with different exponents being multiplied together. You can add them. That's how we combine them, like 5 squared 5 squared times 5 to the third equals 5 to the fifth because we add the exponents. And the same thing, with the subtraction. So if we have like 5 to the fifth over 5 to the second, we would do 5 minus 2. And so the logs directly relate to exponential equations. It's the same type of rule right here. So here's our first example. So notice we're adding two logs together and it equals another log. So since we have two logs being added together, our rule tells us that all we have to do, since they have the same base, is multiply them together. So 9 times x equals, when we put the log, base 6 of 54. What? We'll try to reconnect. All right. Sorry, son interrupting. So now we can see that we have one log on each side, and this was the rule we learned yesterday. If we have one log with the same base on each side, we can cross it out. So now we got 9x equals 54. Last step, divide both sides by 9 to get x by itself. So x equals 6. So remember, we can't cancel out logarithms until we only have one on each side. So here's another example. Notice this one has subtraction. So the subtraction rule was that if they have the same base, put the first one over the second, top minus bottom. And we got log base 8 equals 4. And again, same rule. We got it down to one log on each side. Get rid of them, cancel them out. So I'm going to rewrite this and have 48 over x equals 4 times 1. Because hopefully when you're looking at this problem, you're thinking, oh, I got to cross multiply. So you got 4 times x and 48 times 1. Last step, divide both sides by 4, and we get x equals 12. So here are two of them for you to try. Go ahead and pause this and try them, and then I'll show you the answers. So if you have questions about this, shoot me a message and I'll work these out for you. All right, this text looks really weird. So the power property, when we look at this, notice that if we have a logarithm and we have an exponent right here, what we can do is move it out to the front. So notice, or we can go the other direction as well to make it easier to solve. So if we have a number out in front of the logarithm, we can turn it into the exponent right here. So here's our first example of that. So notice we have a number in front of the log, so we can't just cross them out. We've got to get rid of it first, so we got to move it to there. So now I have log base 7 of x equals log base 7 of 8 to the 2 2/3 power. So now we can get rid of our logs because we got the same log on each side, one of them. So now we have 8 to the 2/3. So we have a rational exponent here. So what this is telling us is the number on the top, and hopefully remember this, we'll say x to the m over n. That's our exponent. Oops. And the number on bottom is our root. So this is telling me to take the cube root of 8. I'm looking at the root first. I like doing the root first if I can. So the cube root of 8 is 2 because 2 times 2 times 2 is 8. So we take the cube root of 8 and get 2, and then we square that. 2 squared is 4, so our answer is 4. Again, you can use a calculator, type that in, it'll give you the same answer too, but try to do it in your head. All right, so our next example here. I'm going to change this. I don't like, for our purposes, that's going to be 2 times the log base 8 of x equals the log base 8 of 81. So we've got to move this guy to get the log by itself. So now we have log base 8 of x squared equals log base 8 of 81. Now we got the log base 8, 1 on each side, we can get rid of them. So we have x squared equals 81. So now we can take square root of both sides. Put our plus and minus in front. So now we have x equals plus and minus 9. So we have to pay attention on this problem because notice that we have two different answers. X equals, well, pen's not working. There we go. X equals 9 and x equals negative 9. Remember our rule that we can't have anything negative in this spot here. So notice that if we plugged in our negative 9 there, that we would have a negative there. So this is not one of our solutions. So our only answer is x equals 9. All right, so here's another example, a little different type of problem because notice there's no logarithm on the right side. So the first thing we need to do is combine the logs on the left. So log base 5 of x minus 12 times x plus 12 equals 2. So now, what are we going to do? Who knows, right? Because we can't cross out the log. Hopefully you remember our rule about rewriting them in exponential functions. So we can say first to the last equals what's in the middle. Oops, there we go. So we know 5 squared is 25. And now I'm just going to use FOIL or the box method to multiply this out. So first times first gives me x squared. Outer gives me positive 12x. Inner gives me negative 12x. They're gone. And last times last gives me negative 144. So now, you guessed it, we're going to get x squared by itself by adding 144. Move this guy up here. So that gives us 169 equals x squared. So now we take square root of both sides. Again, positive and negative when we take square root of a number. So square root of 169 is 13. So we have two solutions here, positive and negative 13 equals x. So now we need to look back up in the original problem and say, well, if we plug in either one of those, do we get out a negative number? And yes, we do. If we plug in a negative 13, we get out a negative number for those. So that the negative 13 is not a solution. So we only have one, which is 13. All right, so here's another example with only logs on one side. So notice this one's addition. So we're going to combine it by multiplication. So we have log base 10 of 4 times w equals 2. And then we can rewrite it. First to the last equals the middle. So now we have 10 to the second equals 4w. So that's 100 equals 4w. Now we just divide both sides by 4. and we get W equals 25. So that's the type of problems you're going to be practicing today. If you have any questions, shoot me a message.